Hello everyone. Today we are going to deal with the very important and the first type of epidemiological study, that is descriptive epidemiological study. Now, as we have seen, there are various types of epidemiological study. The very first and the very basic one is descriptive epidemiological study, and today we are going to discuss its various steps. So to start with, the descriptive epidemiology deals with first step, that is defining the population at risk. Defining the population or the sample of the population. First of all, we have to choose a population. Second is defining the disease. Now, for defining the disease, now this does not mean the scientific definition that we used to give and describe what a particular disease is. But here we have to give an operational definition, which is the definition by which it is the definition by which the disease or condition or a particular condition can be identified and measured in the defined population with a degree of accuracy. So now this is a definition by which we can identify that particular disease within the community. This third step is describing the disease. Now this forms a core of epidemiology, because here we deal with the very basic step, that is all about what is descriptive epidemiology, that is defining anything in terms of time, place and person. So describing the disease in terms of time, place and person. So in this entire video we will be also talking about under these headings only. Then comes the fourth step, that is measurement of disease. Whatever we have described, we will measure it in terms of mean, median, mode, average value, standard deviation, variance, variation and so on. And then we'll compare them with the known indices, like what was earlier the value of IMR and now what is now the value of IMR. This is what we compare, and then we'll formulate a hypothesis based on that. So we have already seen that in descriptive epidemiology we deal with the formulation of hypothesis, whereas in analytical epidemiology we deal with the testing of hypothesis. So now coming on to the third step, that is we start with describing the disease in terms of time, place and person. So first of all, we can describe the disease in time distribution. Now time distribution, diseases can have short-term fluctuations, long-term fluctuations and seasonal or periodic fluctuations. Now these short-term fluctuations are known as epidemics. What they are known as? Epidemics. Whereas periodic fluctuations first of all, talking about long-term fluctuation, these are known as secular trends. We'll be discussing each one of them in detail. And the third, that is periodic fluctuation, this is also known as cyclic or seasonal variations. Now talking about epidemic, this is a very important thing. What is an epidemic? So epidemic is sudden rise in number of cases which is clearly in excess, now how much excess? Which is basically more than 80% or more than 2 standard deviation than the expected population, more than the expected population. So it is the unusual occurrence of a disease or a condition in a particular area. It is not the usual occurrence of that disease in that area. But how much unusual? More than 80% or more than 2 standard deviation of the expected population. Now the types of epidemics. Epidemics can be slow epidemics, where there is a gradual rise of disease, like we have diabetes, mellitus, obesity, where there is a gradual increase of the disease or the mental health problems. Then we have common source epidemic, then these can be of two types, single exposure and multiple exposure. A good example for single exposure is food poisoning. Now here if you see a graph, it will be like this. So there will be primary wave within one incubation period. So यहाँ पर there is only one incubation period and there is a primary wave. So this can be outbreak or an epidemic state. Outbreak or an epidemic state. Then comes the multiple exposures, where you have another example that like a contaminated well, where multiple times from the same well there will be exposure. So now in this case you can get multiple waves like this. So here secondary waves are present and they extend beyond one incubation period, extends beyond one incubation period. Okay, these can be hyperendemic states. Hyperendemic state. Then comes the propagated epidemic, that is spread from one person to another. Spreads from one person to other. There is gradual rise in number of cases or can sometimes be explosive also. Now here what happens is that there is higher secondary attack rate and decreased herd immunity. That is why it is spreading from one person to another. Okay, like gradual decrease you can see is over only a long period of time. Only if susceptible population decreases and the herd immunity increases, like in case of dengue, malaria, HIV/AIDS. Then spread of an epidemic depends upon three things. First is herd immunity. Second is what? We talked about secondary attack rate. Second is secondary attack rate. And third is density or chance of contact with the cases. So chance of contact with cases. Now talking about second thing, that is periodic fluctuations. Now periodic fluctuations can be seasonal trends, like various seasons you have different types of disease. Like in winters, what kind of disease you get? Higher chances of your upper respiratory tract infections. Then there can be higher chances of stroke, MI. Then in summers, or rather in spring, if you see, you have measles, varicella. In summers, you basically get increased cases of gastroenteritis. And in monsoons, what you get? Fortunately or unfortunately, we have all four seasons, so we get all four diseases here. You have more cases of road traffic accidents, snake bites, then your favorite, dengue, malaria, etc. Then come cyclic trends. Like if you see measles, there is an outbreak. It is a 2 to 3 year cycle. After every 2 to 3 years you can get measles. Or if you, for influenza cases, you can see in every 7 to 10 years there is an influenza outbreak. Okay, and similarly rubella has got 6 to 7 years. Then comes long-term fluctuations, where there is a disease can increase or decrease. Disease can increase or decrease, but it will happen over a long period of time. Now, can you tell me certain diseases which have increased during long period of time and certain which have decreased? So increased one, if you talk about, these are non-communicable diseases like diabetes mellitus, obesity, mental health problems. And what have decreased? Decrease, you can see, you can have cases of TB, tuberculosis, diphtheria, polio, plague. These cases have decreased over the time because we have been acting upon them. But what we have been ignoring, they have been constantly increasing. Then comes place-wise distribution. Now there are certain diseases which are common in India, certain common in Japan, USA, India, etc. So in Japan you can get what? Increased cancer stomach. Whereas in USA you have increased chances of CA breast. And in India you have increased chances of CA oral and CA cervix. In developing countries you have increased chances of CA cervix, whereas in developed countries you have increased chances of CA breast. So this is place wise distribution. Now one thing that I want to let you know is about migrant studies. Now in migrant studies what we do, we compare diseases occurrences in the migrant to that of the local population, to that of the local population, or that of earlier population, or that of earlier population. Now what do we get by doing this? See, when we have to test the genetic basis of a particular disease, like we say that cancer stomach is very common in Japan. So now to compare, to know that whether it is a genetic factor की वजह से हो रहा है or it is due to the environmental factors, what we'll do, we'll compare the occurrence of this disease in the migrant population, that those people who have migrated over there and those who are already living there. So if it is happening more in people who are already living there as compared to those who have migrated, that means it has got a genetic origin. It is not related to the environment. Now this does not mean that we have to do this study in people who have migrated 2 days back. No, people who have been living here for so long, but still they are migrated population over here. Okay, and now third comes person distribution. That disease varies from person to person because of his age, occupation, marital status, and many more things. So if we talk about age, now if you see age here, so measles, when you talk about, it occurs in children, whereas rubella has got a bimodal distribution. It occurs in both the population, bimodal distribution. So it occurs in less than 3 years also age, and at 10 to 16 years of age also. Similarly, you can get Hodgkin's lymphoma, which has got a bimodal distribution. Then gender, certain diseases are more common in males. Now males are very tufani, they do all that shit kind of stuff, so they can get snake bites, they do stunts, so they get road traffic accidents. Whereas females in basically rural India, they are exposed to smoke, so chulha smoke, so they get chronic bronchitis. Okay, then difference is also coming on ethnicity, like which place do you belong. Certain diseases are common to certain ethnicity, and certain ethnicity do not get a particular disease. Then marital status, like there is incidence of increased incidence of CA cervix. CA cervix chances are less in nulliparous women. So after you get married, more baby number of babies, more chances of CA cervix. Whereas various occupations expose you to a particular kind of diseases also. Then the socioeconomic status. Certain diseases are common in particular socioeconomic status, whereas certain are common in other socioeconomic status. Similarly goes with behavior, stress, and migration. Then comes formulation of hypothesis. First of all, tell me what is hypothesis. Hypothesis can be said as assumption without proof. You make a particular assumption, like sleeping more causes stress. So this is an assumption. It has not got a proof. Now you have to prove it. How will you prove it? You will prove it by doing analytical studies. By descriptive studies, you can just make assumption without any proof, that is formulation of hypothesis. So after describing a disease in terms of time, place and person, what you have to do, so after describing the disease, you do measurement of disease, then compare with known indices, and then formulate hypothesis. What measurement will you do? So descriptive epidemiology may use a cross-sectional study or a longitudinal study to obtain estimates of magnitude of health and disease problems in human population. So now what are the uses of descriptive epidemiology? First, it can help you know the magnitude of a disease. By doing a cross-sectional study, you can know the magnitude of the disease. Then clues to disease etiology. Then background data for organizing and evaluating. And then it can contribute to further research. So this ends this very important topic, that is the steps of descriptive epidemiology. Usually it can be asked as a long question. Here we have 6 steps usually. First we define the population, then we describe the population, then we describe the disease, then we measure the disease and then compare with known indices, and then formulate a hypothesis. You can get it as a long question also, or as an answer in brief type of questions. And this is a very important topic. In further videos, we'll be discussing now analytical studies. Thank you so much.